Here is a quick video about how this car works. We can see that the car is deviating the obstacle it faces. For example, we can see that it's not hitting the hand, but rather it's taking a new path to avoid it. When you place your hand in front of the left ultrasonic sensor, the right wheel stops in order for the car to make a right turn to avoid the obstacle. And the opposite is true. We need for this circuit are 8 diodes, one 105 capacitor, one 10 microfarad capacitor, and we need 4 resistors. Photocell, we need 2 inverters, we need 2 ultrasonic sensors, one 5-volt regulator, and 2 MOSFETs.
As you can see here, this is a modified version of the V-Speed circuit from Lab 9 that uses a resistor and a photocell instead of a potentiometer. If we come up here to our ultrasonic sensors, as you can see, this circuit has changed a lot from Lab 9. The one big difference is that we are using 2 ultrasonic sensors instead of 1 potentiometer to control V-balance. I'm just going to focus on the left sensor. First, we need to input something into VCC. VCC requires a voltage of at least 5 volts but does not work with 9 volts, so we use a 5-volt regulator to make sure that the ultrasonic sensor gets the amount of voltage it needs. We also need to enter a square wave into the trigger pin. We do this by using a capacitor, a resistor, and an inverter. We ground the ground pin, and then our output is echo. We just put echo through one inverter, and then we invert it again. If we do not do this, the wheel will actually speed up instead of slowing down, which means it will turn in the wrong direction. We do the exact same thing for the right ultrasonic sensor to control the other motor.
First, we will test the ultrasonic sensors. As we can see, the duty cycle is relatively stable. However, when you move your hand closer to the ultrasonic sensor, the duty cycle decreases in order to allow the car to turn to avoid the obstacle. Now we will test the photocell. As you see, when we place our hands closer to the photocell, we place a shadow, and thus the duty cycle decreases in order for the wheels to slow down. When we remove our hand, the photocell is exposed to more light, and thus the duty cycle will increase to allow the car to speed.